What is the value of kinetic energy of an object at the end of a displacement? Whereas the value of kinetic energy and the displacement and the force applied on an object is given in the question. So we can calculate the value of kinetic energy of an object at the end of displacement by using work energy theorem, which states that the change in the kinetic energy will be equal to work done by the force. And here the change in a kinetic energy can be written as K final minus K initial is equal work done. So here the question is about calculating the final kinetic energy. So we can rearrange this equation as final kinetic energy is equal K initial plus work done. So here first we need a value of initial kinetic energy and work done. In the question there is a detail about the initial kinetic energy which is given as 10 joule. So here we have to calculate the value of work done first. It's known that the work done can be calculated using a formula force times distance, whereas the value of force is given as minus 2I plus 3J in terms of vector, whereas D is given as 3I. So here we can do the dot product. So the work done will be equal to minus 2I plus 3J times 3I. So when we are simplifying this, we will get work done as negative 6. So now we have a value of work done and we have a value of kinetic energy. So the final kinetic energy will be equal to 10 minus 6, which will be equal to 4 joule. So the correct answer for this question is option C here.